Hello and welcome to another Minitab Express video for statistics. So what I'm going to be doing today is some of the stuff from chapter 5. Specifically, I'm going to show you how to do some probability distributions the easy way. And I'm going to get into how to do some calculations on a binomial distribution if you don't want the entire thing. So if you haven't watched the lesson video today, a lot of the terminology I'm going to use you will have never heard before, and this will be super strange. So I really kind of want you to make sure you view that first. The other thing to keep in mind is I need to say less. Just kidding. Well, yes, that's actually true. I just did it again. The other thing to keep in mind is that since we have no data this week, you will need to open a copy of Minitab Express ahead of time to be able to use it. And essentially, we're going to be using it as a calculator to do our calculations. So my first example today and my second example will be on using discrete probability distribution. So just producing the tables that give us the distribution of what all probability values will look like for those two. So this first example you should be kind of familiar with because I did it a bunch in the video. We have a bank that believes that if it closes early on Friday and is open on Saturday mornings, that's what its customers are going to prefer. How certain are they? They think about 80% of customers think that. And they're going to look at a random sample of 8 customers. They want to see how many of each of those people in 8 might prefer those Saturday hours. So what you've got here is the random variable x. For this one is going to be the number of customers who prefer Saturday, and then we're going to look at all the different values that x could be. Since there are 8 people being surveyed, it could be that 0, it could be 1, it could be 2, it could be 3, all the way up to 8 that prefer this method. So we want to calculate the probability that we get each of those. So actually in Minitab, and this is kind of interesting, the first thing I have to do is give it all my values. So although you won't have to do this in every version of Minitab, oops, I didn't start at 0. That's a cardinal sin with the binomial. Keep in mind you could have no successes, and that's always a possibility with a binomial. So we always start at 0. So with Minitab Express, and this is not true for every version of Minitab, the first thing you have to do if you want to get the whole distribution is list out all the possible values that you could get. So this is not true for every version of Minitab, just keep that in mind. So in order to produce the distribution, we're going to go up to Statistics, select Probability Distributions, and then Probability Density Function. If you want a cumulative, like what that table I showed you in the notes does, that's the value, that's the option you'd select. I actually never use that one. I don't know why I'm talking about it, but we're going to be using Probability Density Function this time. All right, so we don't want a single value to be inputted. We want to input this whole column we just made, so we need to tell Minitab that. By selecting column of values, it's going to ask you which volume you want to choose. And ours are all in the variable I named x, because x is going along with my variable over here that I have in the Word document. And then I'm going to change my distribution style to binomial since that's the one we have. You'll notice there's a lot of them in here. And like I said in the video, we only do a couple of what's out there. We only do what's really necessary for business. So if you're wondering about what some of them are, that's what it is. And then I'm going to select my number of trials. This is how many individuals are in my sample or number of times I'm going to repeat an event. So for us that's going to be 8. And then my probability of success, that's going to be them selecting Saturday, which we're about 80% sure. Let me see, for clarity in the video I like to include all the zeros. You don't have to do that, you can just type in 0.8, but to help you guys see it on the video, 0.80. So I've got this outputting as a table of probability density values that's going to make it show up in the session window. If you want, you can also select this lower radial button and that'll place it down here in the window below. I think I'll do it this way first and then I'll go through and do it again and show you how it shows up elsewise. I'm going to go ahead and hit OK. And that's all she wrote. There's the completed table. So if you wanted to, you could just copy this table and paste it into your Word document. But I'm going to select Make Similar to do this again and show you what it gives you for that other radial button option. So if you hit that Make Similar button down up at the top, right below, right above the thing that you just made in the navigator, it gives you this option to redo what you just did. So I'm going to select the other radial button so that it stores it in the column next door. And there you go. So I like this a little bit better for copying purposes if you already have your table laid out. Like I do. So I can just paste it into my document and it pastes terribly. Okay. Let's just give up for the day. Let's undo that. That looked horrific. Oh, Minitab, you're doing me no favors today. Let's try copying and pasting the whole thing and see if that looks a little nicer. There we go. Yay! X, P of X. Notice that it says PDF, that stands for probability density function. It stands for just doing one probability each. And again, the cumulative probability accumulates. Actually, let me just go ahead and get rid of this because we didn't end up using it. There we go. Butamus. Let's do another example. So suppose we look at inherited blood type. In case you didn't know, you inherit blood types from both a combination of genes from each of your parents. And if you have somebody whose parents are an O and an A, the probability the child will have type O blood is 25%. And different children independently inherit their genes from each other. That's the only reason why we're going to be able to use the binomial. So independence is incredibly important. Each child or each birth is considered independent of each other, and that will allow us to actually calculate this, which is kind of fun. So we wish to explore the number of children out of 5 born to these parents that will have a type O blood. So what I want to do is I want to create a table of this, and as I've already seen, Minitab just doesn't want to do that right, so let's go ahead and delete that. And so I'm going to create a new variable in here for me looking at number 2. So I'm just going to call this num type O because it looks like I'm writing the word typo. Oops. So this is going to be the number of children that have type O blood. So it might be 0, might be 1, might be 2, might be 3, might be 4, or it might be 5 because they're going to have 5 kids, just like my sister. So here we go. We're going to go back up to statistics, probability distributions, oh, my mouse moved, sorry, probability density function. And again, it's going to ask you, do you want to use single value? No, here I want to make a column. I'm going to be using the num type O column. I'm still using a binomial. My number of trials is 5 since they're having 5 kids. My probability of success is 25%, since 25% of children will have type O blood if their parents are an O and an A. And then I'm going to ask it to store the probability density values in a column. So it'll throw it in C6 for me. And there is my table. Woohoo! So if you remember me doing the one in number 1 in our notes, it was a little bit of a disaster. So if you hate how this looks, I apologize, but this calculation is so much faster than doing it by hand. And if you want, you can use the draw tables option to make this into something. Oh, that's the wrong draw option. Draw tables option on this to make it look a little bit nicer, so it actually does form a table. So that's it for creating probability distributions. We're going to go ahead and use the binomial distribution to do some calculations. So these calculations are designed for you to find single probabilities. So suppose Erin, so this is based on a friend of mine who I took chemistry with back when I was in college, who she never wanted to study for quizzes. So she just sort of guessed on every quiz we had. There were always multiple choice in my chemistry class. So she would just Christmas tree it and call it good, like make patterns and hope something interesting happened with it. It was not a good decision. Let's further on through A through E figure out why it's a bad decision. Anyway, so suppose Erin is going to guess on a multiple choice 10 question quiz. So there's 10 questions we're looking at, and each question has 4 different choices. So the first thing we need to set up is how this looks as a binomial. So I want to keep track of how many she gets correct. So this is going to be the number of questions correct out of 10. And that out of 10 tells you exactly what n is going to be. That's my number of trials, aka my number of questions. And then my probability of success, since she's guessing on all of them, that's supposed to be little p, and it wants to always correct these to being capital, and it drives me nuts. That should be little n. Since she's just guessing and there's 4 choices, 25%. You ever done one of those multiple choice quizzes or tests where they like more than one answer is correct? Always drives me crazy. Anyway. Well, at least you drove me crazy when I was a student. I'm assuming you guys are the same. So look at this, you're like, hey, there's her probability of success, 25% since she's guessing. And the reason we're allowed to do the binomial on this is because she's doing the whole Christmas tree method. She's just randomly guessing on all of them, so they're all independent of each other. She's not doing anything where she knows they're related or anything like that, or even bothering to read them sometimes. It was an experiment, to say the least. Anyway, so we're going to find the probability that Erin gets exactly one of these correct. So I'm going to show you two different ways to do this on Express. One of them I like a little bit more than the other, but no matter what, we're going to be finding the probability that she gets just one of them correct, which should be kind of fun. Oh wait, no, this one I'm going to only show you one way. Sorry. Boy, I'm good at misspeaking. I'm going to show you one way to do this for now and then show you another one later. How's that work for you? It's a good day to be alive. So to do this at first, oh, I'm on Word. Hold on, I got to click over on Express and activate it to get my tables up top. So I'm going to go to Statistics, Probability Distributions, and then Probability Density Function. I want a single value. The value I'm interested in is 1. Are we all clear on where I got that 1 from? It's this. The fact that I want one correct question. We're doing a binomial, so I got to change it to that. She's going to be taking 10 questions, and she's going to get just one of them right. And her chances of getting them right is 25%, or 0.25. Notice that with Minitab, it's using the true value of probability, so it's always using the decimal. It's never using the percent, which is just another way to represent probability. We technically consider probability always between 0 and 1, so you should always be calculating it as a decimal. All right. So I'm going to have it display it, just output it for me, rather than putting it in the table, or in the session, sorry, in the worksheet below. So I'm going to hit OK. And there is Erin's probability. So, you know, this probably wouldn't convince her very much because she's like, oh yeah, I might get one right out of 10. You should look at this and say, okay, 1 right is kind of small in probability. Did I expect it to be bigger? Well, yeah, you should expect it to be bigger. The chance that she gets only 1 right when she's just guessing, when there is a 25% chance that she's going to be correct out of 10, should tell you that on average she should get 2.5 correct. So make a little note to yourself, hey, you know, the mean or the expected number correct she should get is n times p. So 10, not 1, not 0, sorry, times 25%, or 2.5 questions correct. So what's interesting is that means 1 is a smaller probability simply because she should have gotten 2.5 correct. So it's less likely she gets fewer correct than what she's expected to get, which would be 2.5. All right, to even more convince you on how that might work, let's look at the probability she gets none correct. So x equals 0. Woohoo! So I've already used this button once before, but since I'm just going to be doing the same steps by changing one value to 0, I'm going to hit the Make Similar button and change the value of 1 to 0, and that's all I'm going to change because I'm still doing 10 trials, I'm still having the same success, I'm still using a binomial, and that's why the Make Similar button is great for this pile of questions in particular. So because you're going to be doing the same kind of distribution multiple times to answer multiple parts. Let's hit OK. And that one's even smaller because again, she should get about 2 to 3 correct, not 0 or 1. That's why these are so small. Please notice that I'm typing my answers in and writing my probability statements because reading the Minitab versions are kind of weird. You kind of got to read them down and across. Strangeness, epic strangeness. Okay, so let's take a look at C. So here we're going to look at Erin getting at most 4 questions correct. So the most she got right is 4. That's really small. Hold on a second. I'm trying to make these bigger so you guys can read them while you're looking at it. So she wants to get 4, at most 4 correct. So it could be 4, it could be smaller. So I want you to think about what goes in between x and 4. So it could up to 4 of them correct, but also it could be less than. So I want to do less than or equal to here. So I'm going to go to Insert, Advanced Symbol. Come on. Why does this not want to work all of a sudden? Okay, I just spent 5 minutes finding that less than or equal to, so that's super annoying on a Mac. Fun fact. Either way, I'm going to show you 2 ways to do this one, both equally interesting. So what we want to do is we want 4, 3, 2, 1, or 0, and we want to add them all together. So we are adding, aka accumulating. So to do that, I'm going to be using the cumulative distribution function this time. So we're going back over here to Minitab Express. We're going to be going to Statistics, probability distributions, and now I'm going to be choosing cumulative probability distribution function. This is not my favorite, but hopefully it makes sense. So again, I'm going to be wanting a single value. I want 4. I want to do a binomial. I'm going to change this to 10 trials at 25% being correct. I'm going to have it display it rather than storing it in a column. We should be good to go. So notice it looks exactly the same as the previous menu, so you've got to be careful with this. Except for it's got this cumulative or accumulate idea going. I'm going to add them up. So notice the symbolic difference here, less than or equal to 4. So 0.4, sorry, 0.92. Oh my gosh, I'm hitting all the wrong buttons. 1873. And obviously if you're asked to round this, you can round it. So that's one way to do this one. But this is also a great opportunity for me to bring out something else in our toolbox that I like a lot better than the statistics menu for doing this. So this is about where the usefulness of that option I've been showing you on how to do A, B, and C ends. Because if you look at D, it's at least, and this will only do equal to's and less than or equal to's. So we really need another tool. So let me show you another way to do this one for fun. And I like this way because I'm a little more of a visual learner, and I'm assuming you are too. Well, some of you are at least. So we're going to go to probability and then to distribution plot. So I hit this probability button right here. And then I want to display probability. So just so you're keeping track, that was probability, distribution plot, display probability. And I want to change this up to give me a graph. So I want a binomial. I have 10 trials and a 25% chance of being right. And then I want to tell it to give me some area. So it's going to shade based on values that I want. So I want stuff less than 4. And in particular, I know an x value, not a probability. So I need to change this first. So it's like, do you want to specify probability? Nope, I want to specify an x value. So notice your pictures all change a little bit. And if you look at these, it's like, oh, do you want right tail? Do you want left? Do you want equal to? Do you want middle? And here's where you got to be careful. So since I'm looking for stuff less than 4, that's the stuff to the left of 4 on the number line. So I want left tail. And I want to put a 4 in here. So this is a little bit more complicated, but if you're visual and how you understand things, this will make way more sense to you. Let's hit OK. So see how this looks? So as you look at this, this is your x-axis. It's graphing the probability distribution like we saw some of those graphs in your notes. And it's highlighting in red the area that you're interested in. So notice it's got a start at 4 and then everything less than 4 is red. The stuff in red, the area itself, makes your probability. So if you think about it, each brick is 1 unit wide and so tall as to the probability value. So the area here in red makes your total probability. So the value of probability appears at the top above the red parts. Also, you can hover your mouse over top of the bricks to get specific values. So let me scroll my word up a little bit here. So you remember we did 1 and 0 earlier? You can go on Minitab and just stick that sucker on top of there and look, there's 1. And then there's 0. So I accidentally told you earlier that I was going to show you other ways to do this, and then I changed my mind, and then I remembered, oh yeah, I do it later. Sorry about that. So there's the quick way to do it. So it's almost better when you're approaching these to read through a couple of them first, do one of the ones that's more complicated, and then back up and do some of the easier ones if you like the graphical version. And like I said a few seconds ago also, this one is great if you're going to do less than or equal to's, greater than or equal to's, or in between ones like we have in E, if you haven't looked at E yet. But it's not so great at doing equal to's because I kind of have to hover my mouse to do them. The other way to trick it into doing them is something funky that I'll show you at the end. So if you're real confused by the end of this, oh boy, am I going to be sorry. Anyway, so if I want to do at least 5, because I'm now moving my way on to D, that means the smallest she's going to get is 5, and she could be bigger. So that's going to be a greater than or equal to. Remember, at least kind of corresponds to you must be at least 5 feet tall to ride this ride. So I have to be greater than or equal to that. So I'm going to go back and try to insert some symbology again because that went so well the last time. But this time I know where the greater than is, unlike the other symbol. Greater than or equal to 5. At least 5. Could be 5, but needs to be taller to ride the ride. Alright, so I'm going to go back over here, and I could hit make similar, but I'm going to take you through the process of this one again because you haven't seen this menu happen as much. So I'm hitting probability, come on, there we go, distribution plot, and then display probability because I want it to make a picture. I'm going to be choosing the binomial. I'm entering in my n and my p, my number of trials, and my probability of success. Notice the event probability does not change. That's one of the characteristics of the polynomial. I don't change this when I start calculating things. I'm going to do a specific x value because I know x and I want to find probability. And here is where this shines. So in C, I did a less than or equal to. You cannot do a probability density function or a cumulative distribution function and get a less than or equal to. Or sorry, and get a greater than or equal to. You can only do less than or equal to. So it only goes this direction. So if I want to go right, like this one, well then I can only use this one to do so. Or you can do 1 minus as well to get right. Alright, so I should be good because I'm doing a right tail because I'm doing things greater than 5, which on the number line, if you think about where 5 is, the stuff that's greater than it are like 6, 7, 8, 9, 10, you know, that kind of stuff. They're on the other side of 5. They're to the right of 5, so I want right. Let's hit OK. And there is my answer. So be careful, your answer is the value above the graph. So 0.07, this is tiny, 81269. Do you think Erin's convinced she's going to fail yet? Because the probability she gets like half of them right or more. Oh boy, it's not good. It's just not good, girl. Yeah, remember how earlier we said the mean was 2.5? Like, look at this guy. Like, where is it the highest? 2. And like 3. So right in here. That's where the mean is. And it makes sense when you think about like how this looks. It's not quite symmetric. It's kind of close though. Okay, now to really convince her that she's going to fail, because that's the kind of friend you are. Okay, maybe not. I don't know who you are. It's good. Well, I wish I knew who you were. It's fine. Although this is on YouTube, so any stranger could watch this too. Let's find the probability she gets between 6 and 8 correct. So this is something that we kind of did towards the end, well, last 10 minutes of the lesson video where we were trying to do between 2 and 1. We were only looking at doing one value because of the cumulative distribution we were doing. Here I'm going to do between 6 and 8, including 6 and 8. And this is a little bit more powerful because I can do that. So I'm going to cheat a little bit. I want 6, x, 8. Ooh, that's... Why did that come out so weird? Oh, I was trying to do a capital X and I held the shift key too long. That's why. I'm going to cheat and steal this less than or equal to because it was so hard to find. I got to remember to cut that video, part of the video. I already did, so that's good. 6 and 8, including 8. Now, make a little note above this. Hey, if I wanted, you know, to not include 6 and 8, we would do the probability it was between, well, it would just be 7 because that would be the only thing between the two. X equals 7 if 6 and 8 were not included. Just a kind of little note to yourself so you can keep track of stuff. I hope you do take notes on these videos. I'm not so sure everybody does. Anyway, let's calculate it. B. Oh man, sorry. I'm not used to this mouse. Maybe I should get a different one because I keep screwing up how I do stuff. So I'm going to hit make similar because I'm still in the same distribution, but just to keep track, I did probability, probability distribution plot, and then display probability is how we get this. It's always displaying. Let's hit make similar. So I'm still 10, still 25%. We're going to select middle. So I want between 6 and 8. And you got to be careful when you're doing a middle because you have two x values floating around. Notice the x1 value is to the left of the x2 value. That means when you're doing this, the first value always has to be the smaller of the two, because if you try to switch them up, it'll actually yell at you and tell you, error, no, evil, blah, don't, Anyway, let's hit OK. And there is our probability. It's super tiny. So you're like, girl, the probability you pass but maybe don't get an A is like 2%. It's super small. Don't do it. Maybe study a little, or at least try to reduce your chances. Obviously, if you wanted to increase your chances of passing, you'd be like, hey, can we do 3 choices instead of 4? Or how about try to eliminate one of the options to see if it's correct. Okay, so the last thing I'm going to do is show you a tricky way to do the first question we encountered. So I'm going to sneak back up and do A. So A was I wanted to do x equals 1. And you can actually trick the distribution plot into doing a single value using the middle. So notice this did less than or equal to because it included 6 and 8. Looking back at the picture, you see that 6 is shaded and so is 8. So if you actually pick these values to be the same, so I'm saying like with the 6 I'm going to put a 1 and a 1. It's saying I want to be greater than or equal to 1 and less than or equal to 1. Well, the only thing that does both those is 1, so it'll just shade in the brick for 1. So this is like a tricky way to do this. So we're going to hit make similar. Oops, I almost hit it twice. And so I'm just going to change these two to both be the same. And when you do that, that's a way you can trick the cumulative one, or sorry, the plot one into doing just one value. So if you hit OK, watch what this does. It shades only the one block. Yay! Which is the value right here. So that's just a kind of sneaky way you can do this. Select middle, input the same two values, and it'll give you a single value on here, which is kind of trippy. It's just a sneaky way to get around it. So that's all she wrote for the binomial and other distribution plots. Remember, basically everything we need to do is in the probability button or within the statistics probability distributions button. Those are the only two menus you need to do this assignment and this chapter's worth of homework. Good luck.